Okay, in this video I'll be continuing the last class, that of electrostatics. Okay, so we actually did a problem, right? So we can actually conclude some things from that, from doing problems. If the force is negative, then it is attraction. Or if the force is positive, then it is repulsion. If the force is negative, it is attraction. If the force is positive, it is repulsion. Right? Okay, how can we get to such a conclusion? Okay, you mean it's quite simple. We have a negative charge, and the equation for force, we have to multiply the two charges, right, into a positive constant. Negative into negative gives you positive, right? Therefore, if there are two like negative charges, positive, they repel, right? Therefore, if the force is positive, it's repulsion. Even if it is positive into positive, it is positive, right? Therefore, like charges repel, and the force between them is positive. Okay, negative. Similarly, if we multiply a negative into a positive, we get negative, right? That is why, if the force is negative, then it is attraction. Okay, now I'll be moving on to another concept: electric field. Electric field. Electric field. Now I'm not actually going into the diagram of electric field. I will be just giving you an equation. I will be giving you a definition. Now, what is an electric field? The electric field is actually the charge per area. Charge. Okay, I'm sorry, that's not actually correct. That is, I got confused with charge density. It's not right. So in order to find the electric field, you have to find how much force is there in a particular place per charge per area. Per charge at any point. That is how you find the electric field. Find how much force is there per charge at any point. That is actually force by charge, right? Force by charge. Now, what is force? We actually derived an equation. We didn't derive it. We actually know an equation for force, right? K into Q1 by Q2 divided by d squared. Now, suppose we want to find the electric field for the Q1. Okay, Q1. Therefore, we divide by Q1. They'll give you K. Q1 goes off, right? K into Q2 divided by d squared, right? Similarly, if we want to find the electric field for Q2, we get it as K into Q1 by d squared, right? Okay, now that is electric field. I'm not actually talking much about electric field. It's actually very, a bit confusing. Okay, so I'm actually stopping electrostatics. No, I'm not stopping. I have some more to say. Okay, now I'll be taking something else. Let me clear this off first. Okay, I will actually draw a diagram of field lines, just for namesake. let it be parallel, a different color. Positive and negative. Shit. Negative. Okay. Suppose that we have a charge from here going like this, but it is attracted towards the negative, so it slightly bends and goes like this. A charge over here bends before, goes like this. So this is actually how electric field lines look like. I mean, they're not actual, but they're arbitrary. Okay, this is how we imagine them. Okay, so that's all I have to say about electrostatics. We have more complex things in electrostatics, such as electric potential energy. That's, yeah. I'm not actually explaining that right now. I'm not in a mood to explain that. It's quite complicated. I mean, the concept isn't simple, but to explain it is a complex task. Okay, so in the next one, I'll be giving you something, something like what I gave for electrostatics for magnetism. Okay, bye bye.